Okay, good morning again. My name is Vincent Nguyen, and I have the chance to lead Ubiqus for the past 15 years now. And for those who do not know Ubiqus, I will try to introduce a little bit the company. Ubiqus was founded more than 25 years ago. It was established in Paris at the beginning, and the very first service was summarization, and it had nothing to do with IT. It was just sending writers on site, taking notes, and writing a summary. And we developed this product during the first 10 years, and at the beginning of 2000, we started to go international, and we established some offices in the UK, in the US, and now we are also in Belgium, in Spain, and in Canada. So we achieved 70 million euros in revenue last year, which is split 45% in translation, 30% in summarization, and 20% in transcription. So now you understand why NLP is so critical for us, because from regular human service, we are now switching to machine-based service for almost all the services that we offer today. And we have been working for on speech recognition over the past 3 years for the transcription service. And we have been working on machine translation when Moses was out and the best toolkit out there, but we embraced OpenNMT. From day one, it was released open source. And later on the day, also we'll have someone from my company and working also with an academic, working on automatic summarization, what Sasha talked about a little bit earlier. So we have a small but very active R&D team working on these three areas for translation, summarization, and speech recognition. So the talk of today is not really about Ubiqus, it's more about OpenNMT evaluation and NMT evaluation in general. As you said earlier, benchmarking toolkits is a very difficult task. It requires an extensive knowledge, and we have been spending hours and hours and weeks on training using various toolkits. And we started, of course, with OpenNMT because it was the easiest one. But then we wanted to compare and to make sure that we had the best toolkit and the best engines for our business. So you need to be very thorough on the setup, because when you want to compare the various toolkits, it's very important to get the real sense of all the hyperparameters that you use for the training. Also, you need to do this in good faith and independence. And Ubiqus, if we had a better toolkit or an easier toolkit, we would just switch from OpenNMT to another one. But so far, we have found this to be very competitive in terms of results. It's very quick in terms of speed, both for training and translation. It's a very good one. And also, there is a very big user community, and there is various users coming from around the world and making this community very active. And of course, what is very important to us, and I will talk a little bit later during this talk, OpenNMT is trying to keep pace with all the innovative architecture and to facilitate the usage with this NMT wizard. But we will see that OpenNMT is also trying to implement the new architecture like the transformer. So let's talk about real evaluation, and most of you really know what a BLEU evaluation is. So the bilingual evaluation under study has been the best or the least worst tool to evaluate machine translation, and this is the case. This has been the case for years now. There is sometimes misunderstanding about what the BLEU score, what a good BLEU score is, because at the time of SMT or even rule-based machine translation, when we were gaining like an additional half a point or 1 point, it was a huge achievement. Now it's just about a very poor achievement, and we expect, and all the users expect, like 2, 3, 5 more points in BLEU score. So in the real world, what we observed and what we've been trying to look at is a very high BLEU score with in-domain data, so that it's really usable for an industrial context. So when we consider that mostly for European languages, the BLEU score is less than 40, it requires a heavy post-editing for delivering a very good human translation. When the score is between 40 and 60, it requires a light post-editing. And when you have more than 60 in BLEU score, I'm not saying it's almost perfect, but there is a very light proofreading and post-editing. So when this refers to a paper from Google 18 months ago about undistinguishable translation between the machine and the human translation, the score that they released, for instance, for English to French, was about 38 or 39. So I wouldn't say it's indistinguishable. I mean, there is a big difference, and it really requires post-editing when you want to deliver a high level and a high quality translation to your customer. So no measure is perfect, and when we discuss about BLEU, we also can discuss about translation edit rate or the Levenstein distance on a per character basis. But again, bear in mind that when you do a BLEU evaluation, it's always, or most of the time, based on just one human reference. And a human reference is just one reference. And you could have like a tens of 10 different references. So let's look at real numbers. And I'm sorry because the presentation is a little low and the numbers are a little small for the back end of the room, but this talk is really started with some poor results that were shown about OpenNMT in the literature and on the website. So I would my intention was a little bit to offset these poor results and to show that the toolkit is very competitive. So the first number that we released was actually from our own paper. When I say our, I'm just embracing it, but it was more the Harvard and the Cistron paper. And they were more focused on the technology itself, and it was just a baseline result. So the first BLEU score that they released was 19 for English to German. But again, it was a very baseline result, and it was not based on the best tuned parameters. And also, at the very beginning of the project, they released on the website, on the OpenNMT website, a pre-trained model for English to German. And the score was 17. So when you know a little bit about the English to German machine translation, these scores look very, very, very low. And the thing is, when you just release some such scores for baseline systems in the literature, they are taken by others and they are put in their own papers. So there is one guy from Google, Denny Britt, who is another implementer of another sequence-to-sequence toolkit, did a massive exploration of NMT during the year, at the beginning of the year 2017. And it just took the number from OpenNMT of 19. That was just a baseline number. But again, when he compared it, the other numbers were not comparable at all because the settings were not the same, the hyperparameters were not the same. And more recently, someone in the room mentioned the Sokai paper. The Sokai paper was released in December, and they tried to compare various toolkits. The OpenNMT Lua, the Python version, MarianNMT, Nematus, and EuroMonkey. And you can see that the results are very, very different. And we were a little bit upset by the fact that OpenNMT appeared almost 4 points under the best scores. And that's what we wanted to look at, because believe it or not, the OpenNMT team has been focusing on technology and developing features and everything, but they never did an actual evaluation based on the standard WMT tasks. So that's what I tried to do, and I tried to do it not waiting weeks and weeks of training, just trying to have like a 2 days training or max 3 or 4 days training. So we took the main task that is the well-known English to German, which has been a very long time reference for in the WMT tasks. And the tasks consist in taking a data set of about, it used to be a little less than 5 million sentences, and they added 2 years ago another data set of 1.3 million sentences. And when you look at the scores over time, when it was at the time of Moses, which was an SMT based, the best scores based on the news test 2014 were about 20. But you know what? It was even lower years ago when we look at the numbers of WMT 11, for instance. In 2011, it was in the 15 or 17 for the English to German scores. And the first NMT toolkit that won, actually, the WMT task was in 15. It was the Montreal group from the Montreal University, the Joshua Benjo group. And starting in 15 and onward, it was just NMT toolkits. So technically, we know that Rico Zeneris from Edinburgh with Nemetus keeps winning the WMT task year after year, but we will see that we are not so far from these numbers. I'm just making it very specific here on the data set. What we do is we take those 5 million sentences, we clean up, because cleanup is very important in NMT, as Jean mentioned earlier. And I also mentioned here the number of sentences depending on how you limit the data set in terms of tokens. If you take all the sentences that have less than 100 tokens, you keep 4 million. But when you limit your data set to 50 tokens per sentence, you can see that your data set it's much lower. It's 3.5 million. And just the size of the data set has a very important impact on the training. So it's not just the size of the data set, but also the length of the sentences are very important. So let's start with a baseline experiment, because that was the first experiment in the Sokai paper. So what we did is that we did a very basic training, which was a very small network, 2 layers of 512 units, hidden units, embeddings very small, 256, and we used a subword BPE of 32K, which is almost the one that everyone uses in this task. And the model was not so big. It was 47 million parameters, and we used very basic other settings. We didn't want to train during weeks, so we just limited to 7 epochs. And the training lasted a little more than 24 hours. So it was just 30 hours of training. And guess what? The BLEU score on news test 2014 was 21.8. So 21.8 is already 2 points better than what it was released in the baseline from the original paper of OpenNMT. And it's already 4 points higher than the pre-trained model of the website. So maybe we will just take this model and put it on the website just to change the 17 to 22. Since it was not exactly the same baseline that the Sokai paper did, we just reproduced the Sokai paper experiment. Sorry, this one is a little low, but it's just very basic again. It's a 1 layer, and the layer size and the embeddings are a little higher than the previous experiment. The same training schedule as above, and the BLEU score was 23.6. And 23.6, well, it's, you know what? It's much higher than the Sokai paper of 19.7. So I don't really know exactly what they did or what they didn't, but the most obvious thing is that they took the default settings of OpenNMT, and the OpenNMT settings are not optimized for this specific task. So that's something that we need to bear in mind, which is when you get it, when you work with a specific data set, a specific task, you need to have some specific settings. You cannot just take the default out-of-the-box settings and think that you will get the best scores with all the various experiments. And it could also depend on the various languages. So the next thing was, okay, so how do we compare if we take a bigger network? So will the bigger network be better? And the answer is yes, for sure, but not necessarily when you work, again, with a specific data set. When you work with a 4 to 5 million sentence data set, it's not the same as when you work with 40 million sentence data set. For instance, the well-known WMT English to French task, which has 40 million sentences, will require a much bigger network. But if you take a too big network for this specific task, English to German, then your model will overfit and you will not get the best results. So what we did is we did 4 different experiments, and you can see that the BLEU score based on News Test 2017, which is what the Sokai paper released on the December paper, we have a score of 25.1, which is not the best score, but which is already 2.5 points higher than what the Sokai paper released for OpenNMT LEU. So again, this is all a matter of settings, and my guess is that the biggest impact comes from the sequence length. When you take a sequence length of 100 tokens, you get a much better score than when you take a 50 sequence length. And you can also see that when you take a bigger network with 4 layers, you doesn't get necessarily a higher score. So you can see here that using the same schedule as the previous experiment with 7 epochs, so it didn't take more than 2 days of training, you can achieve much better than what the default settings out of the box will give you. And again, it's very surprising to see these results, because when you see NeuroMonkey at 14, to me it doesn't make sense, and you can't just you can just compare a network with just 1 layer and Nematius with 8 layers, and so this is very difficult to compare toolkits. So we need to have like a good sense of actually what we are doing. So just to illustrate a little bit more about the sequence length, at the bottom right you can see here that when you limit the sequence from 100 to 50 based on the exact same network, you gain 1 BLEU point more with the 100 sequence. So technically, how do we compare to the best RNN toolkits? I would say that OpenNMT LEU is a bit below with the best tuned system that are out there, and but it's still much better than what's been made out to be, and how it was presented in the literature. But we are still a little bit under. So here we compare on the same task the Google NMT with what they call GNMT attention with 4 or 8 layers, and you can see that the OpenNMT LEU is a little bit lower than the Google NMT 4 layers. So we are 0.5 points lower than the best tuned systems. But still, we are much higher than what it used to be for the WMT task at that time, and for the news test 14 and 15. I would say it's just a personal opinion on this. It's not a sense that I can prove, but I really think that in OpenNMT LEU there are 2 key missing features, which is the label smoothing, and I'm pretty sure that what we have observed with label smoothing in some other toolkits, it could bring almost 1 BLEU point, and the GNMT attention is also the one of the single feature that has not been implemented in OpenNMT LEU so far. So if those 2 features are implemented in the short term, I'm pretty sure that we will get still state-of-the-art results with OpenNMT LEU. But in a way, what is half a point? Who really cares? Because what we observed is that when we add more data to the training, it will improve by far the results, and that's been proved by the last 2 WMT tasks. Rico Zenrig, the guy from Edinburgh, released the back translation that he used for the WMT 16 task. It was an additional 3.5 million sentences that were back translated from German into English, and they added those 3.5 million sentences to the dataset for the training. And it has a tremendous impact on the BLEU score. The BLEU score that he got for the WMT 16 system, the best one was 34. See, so it's a much higher score, and he obtained this result with an ensemble of models, and if we take his best system as the best single system, the score was 31.6. You can look in the literature and on the WMT results. This is exactly the result of the best single system from Rico in WMT 16. I did the training with these additional 3.5 million sentences, and I obtained 32.8. So you can see that OpenNMT with additional data is already better than the best single system at that time. And it was very close to the best ensemble system. So we did it again for WMT 17, which is the last WMT task. The only thing is for the last WMT task, Rico didn't release the new additional back translation, and he used 10 million additional segments. So since I didn't have those back translation, I didn't want to do it myself. I reused the same back translation that were used for 16 to the 17 task. And you can see that we are already at the same level as the best single system. So we are slightly under the best ensemble system, but we are at the level and even a little bit higher than the best single system. So again, what I would like to mention is that when you add more data, the difference is even lower, and OpenNMT is highly competitive. So still, do we think that all these results show that OpenNMT is state of the art? Of course not, and all of you know about the last paper from Google Brain that was released in June 17. Attention is all you need. So the so-called innovative transformer model. So it's not an RNN, it's a simple feed-forward, but with multi-head attention. And when they released the paper, it was a real breakthrough, because they released a new state-of-the-art on News Test 14 of 28.4, which was almost 4 points higher than the best Google NMT model that I presented just earlier. And it was 5 points better than our OpenNMT LEU. So 5 points, it's a big breakthrough in terms of NMT. And ever since, so over the past, I would say 6 to 8 months, a lot of copycats were released, copycats of the transformer were released. So we have at OpenNMT 2 versions of the transformer, the OpenNMT TensorFlow version, which is very close to tensor to tensor, tensor to tensor being the toolkit of the Google transformer. OpenNMT Pi, it's functional, and as Sasha said, there is some fixes that will be released in the next few weeks, I hope so, and I am pretty sure that the results will be very similar. I have tested the Marianne NMT. They have also their own transformer. It gives some good results. It's just it was supposed to be very fast because it's developed in C++, but I found that the memory optimization was not so good. So, but it's still very promising in my view. I have not tested the Sockeye. I didn't get a chance to test the Sockeye transformer. And NeuroMonkey, I've never tested this toolkit at all. I have tested the Facebook FairSec PyTorch version, which is a convolutional neural network, the thing that you mentioned earlier. And they claimed state-of-the-art results also on some WMT tasks. And I will show you what I obtained and a little bit after that. So these are my transformer results. And again, I've spent a lot of time on the tensor-to-tensor framework. And I can tell you that first, it's very good, it's very fast. But it's a little cumbersome to set up when you want to set it up with your own data. So it's not as easy. It's more research-oriented, and it's not as easy as OpenNMT to use out of the box. So what we have done is that we have taken the same data set without the rapid 16 additional data that was shown earlier in the presentation. So the data set is made of 4.5 million segments. So we trained the transformer with tensor to tensor after 500,000 steps. The new test 14 is 27.3. And if you remember, what they released in their paper was 28.4. So we just took a smaller model, what they call the base model and not the big model. And it's actually exactly the same as the base model. So we were quite confident that we replicated about the same setup as the paper. Attention is all you need. And we ran the same experiment with OpenNMT TensorFlow, and it's slightly under on the news test 14 test set, but it's slightly above for the 17 test set. But what is most surprising is when I get 27.8, the Sockeye paper did a very similar experiment with the tensor-to-tensor toolkit, and they had only 24.8. So again, and it's a 3-point difference. So it's not small difference. So again, it's just to show you that when you do some experiments, the settings that you use are very important, and you cannot just expect with just the first shot of the first experiment to replicate. To obtain this, you need to have worked extensively with the toolkit during weeks and weeks. Even if this training lasts like a few days, it requires a lot of various experiments. So just as a reminder, the best WMT 17 score was 28.3 with back translation. So with an additional 10 million sentences, the score was not even much higher than the results obtained with the transformer. So the question will be, okay, why didn't you do the experiment with back translation? I didn't have the time, sorry for that. So OpenNMT remains really in the game with its TensorFlow version of the transformer. Pretty sure that the Python version will also take into account the full feature of the transformer, and we will keep these results to be state of the art. Because again, as of today, there is no question the transformer delivers much better results than the RNNs. No question, yes, there is a question, and I will show you that it's not so obvious. It is obvious with a single WMT task, but what we did, because we do not work with public data, we work at Ubiqus with in-house data. We did the same experiment with an in-house data set. And the data set that we used was an English to Canadian French data set of about 9 or 10 million segments. So we tried to be fair and to do the same experiment for all these toolkits. So I trained the engine with my best OpenNMT setup, which is actually the one that I have in production for English to Canadian French, and on an in-house test set, which is in domain, I obtained a BLEU score of 44.8. So I was very curious to see what could be the scores with the new transformer or the convolutional networks from Facebook. And guess what? The transformer delivered just 45.5. So you can see that when the data are very in-house and are very in-domain and very close to what you are supposed to translate, the difference between RNNs and the innovative transformer or the CNN, and again, the CNN is even lower when the CNN gives a very good score on the WMT task. So it's not so obvious that when something is proved to be innovative or will deliver a very good scores, when it comes to real-world production and with in-domain data, it's all about the same performance so far. So what I have not done this specific experiment with the 20 different language pairs that we handle in-house, but I'm pretty sure that I would obtain very similar results. And again, don't forget my first slide. It doesn't make a big difference of 1 BLEU point, because even at this level, it requires quite some post-editing by the human translator to get a very high quality translation in the end. So when we talk about state of the art, we are talking just about quality, but quality of the translation. But there are plenty of other considerations regarding a toolkit. First, the translation speed. And all toolkits are not equal in translation speed. I can say that I have tested tensor-to-tensor, OpenNMT LUA. They are very fast. NMT also has a very similar speed in translation. But some other toolkits have a very lower speed. And when it comes to real-world production, this is very, very important. Another important factor is the model loading time. When you run a translation, you need to load the model in memory first. And when it takes like 1 to less than 2 seconds with OpenNMT LUA, when it comes to the TensorFlow versions, whether OpenNMT or tensor-to-tensor, it takes up to 8 to 10 seconds to load the model in memory. So just if you want to keep the model in memory forever during a translation, then that's fine. It's just like a lag at the very beginning of the translation. But when you want to switch from one model, from one language pair to the other on the same machine, and you need to switch very frequently because you have like 50 different users using your NMT, it's very important that you can load and unload the model very fast. And today, it doesn't work very fast with TensorFlow. So LUA is by far the fastest toolkit to load and unload the model in memory. The REST API integration is definitely something that we initiated at the very beginning of the project, and today it's very plug and play. Some other toolkits have a REST API. NMT has a server out of the box as well. And one last consideration in the support and the community. Most of the time when there is a new toolkit on GitHub, you will see that there is one single user that will respond to the issues, to the bugs, to develop new features, and so on. Here, there is a real support and community. It's professional quality support, since Sistron is behind it, since there is a big research community and the Harvard guys behind it. So no question asked. To me, it's the best support. Even though tensor-to-tensor is not so bad in terms of support as well, but each time they have a release, there are some bugs, and the bugs are not fixed just right away. And each time there is a new release and there is a bug, they say, okay, so take the release, take the previous release, but then which one can be used in pre-production? And I would say today it's very, very difficult to use tensor-to-tensor in a production environment. So that was about my talk about evaluation, and I will just give a few words about what we do at Ubiqus using OpenNMT. Technically, the infrastructure is very simple. We use OpenNMT scripts and layers for the very basic NMT implementation. So we have plenty of pairs, up to 20 or 25 various pairs, which are the most used pairs that we have in-house. And we use the open source REST multimodal Lua script, and this enables us to load about 4 engines at a time on a single GTX 1080. And again, if there is a fifth model that needs to be loaded, we unload the most idle one, and it will come up very quickly. And we developed a custom REST server. So this is an extra layer here. And the purpose of this extra layer is very simple. It's to communicate with the SDL Studio plugin, and is to keep some results in cache. Because when you keep the results in cache, when you ask a second time the same query, it's much faster than trying to query again the NMT server. And we have this extra layer, which is a very huge translation memory. Basically, it's made of all the data sets that we have. So we have like tens of millions of segments that can be queried directly as a translation memory, rather than asking the NMT to build a sentence. So this is made to deliver very good scores, and it to be very fast, and to be very fast not just for one single users, but for tens of users. And based on the data that we gather here, all the queries, we build a dashboard, and this dashboard will give us real-time plenty of information. This is just one screen, but we can manage all the users, all the engines, see what is in cache, or look at the console of the NMT server. And this is just the beginning of February. You can see that just in 3 weeks, we handle 4.7 million source words on all these various NMT engines. So all these pairs, and you can see on the various colors that it's not equally scattered, but obviously this is just a European server. So we have exactly the same server for the North American operations, but you can see that the most used French to English, English to French. We also have some specialized engines dedicated for the biomedical, especially from English to Spanish and Spanish to English. And you can see all the different users. And for the first 3 weeks of February, we have like 53 different users. But again, you can see that there are some users that are heavy users because they are technical users that will prepare the pre-translated documents. And we have very light users also using NMT just from time to time. But again, remember, you need a very high BLEU score to convince people that NMT is good, because this is the real world. I mean, people will never just embrace NMT or machine translation in general if you don't show them that it gives them very good scores. And even some clients sometimes will just say, you know what, I don't want to hear about machine translation. I just want a human behind it, because otherwise there will be too many mistakes in the document. So that's why trying to convince all the users, the best way is to show the scores for each job. So what we have done at Ubiqus is that on each single job that is sent by a human translator to our platform, we will score the job done of the human translator against the machine translation. So you can see that it will give a better sense on how accurate the machine translation is for each job. And since these scores are sent on a per job basis to the project manager, it will help to convince them that, oh yes, it's quite good. So I took a good example because otherwise it wouldn't be very convincing. But for an Spanish to English job, we built an in-house score that we call the U score. But if you want to know the BLEU score is 61% for this specific job. And we have the distribution of the segments within the job. So you can see that 1,386 tokens, so basically words, are scored in segments with a U score between 90% or 100%, which is almost perfect. So of course, for this kind of scores, the translator will be very happy to just post-edit the job and not to redo everything. So that was about all my talk regarding evaluation of OpenNMT and what we do in a real-world organization. So thank you for listening, and if you have any questions, feel free to ask or to write on Slido.